Hello, friends. Part 2 of our podcast from Section 7.1 in the AP Stats book. We just finished talking about discrete random variables, the capital letter X, and random variable histograms, where the area under each bar is the probability of an event happening. So let's look at an example. All right, so a typical one you could have for homework, 7.2. Family plans to have 3 children. You can pause and read the question if you need to. Write the 8 possible arrangements. All right, so we said on the first one, they could have a boy or a girl. On the second one, they could have a boy or a girl and then a boy, or they could have a boy, a girl, with a girl. So that's 4. And the third set, I could have any of these with a boy, or I could have any of these with a girl. All right, so there's your 8 possible outcomes. Next question. Let X be the number of girls. So the random variable is the number of girls in the family. What is the probability that X is 2? Well, the probability that X is 2, how many of these have 2? Well, not this one, not this one, not this one. Oh, this one does. This one doesn't. This one does. This one does. And this one has 3. All right, but that's not 2. That's more than 2. So in this case, there are 3 successes out of 8 possible outcomes. And for part C, I'm going to take part C in green. I'm going to make a probability model like we were talking about. So what are all the values that X can take? Well, they could have 0 girls, 1, 2, or 3. And now the bottom of this model has to be the probability of each. Well, there's only one way right here that I can get no daughters. One daughter I could get here, here, and here. So there's 3 out of 8. There's 1, 2, 3 ways to get 2 daughters, and there's only one way. And I can verify that this is a proper probability model by adding up all these probabilities and seeing that they add up to 1. All right, so there you go. These are the kind of questions. So what's new here? Well, we're revisiting this idea of the random variable X, the values it can take, and the probability stuff from chapter 6, probability models, and just understanding what the question's asking. So discrete variables are the first part of 7.1. The second part are continuous variables. Let's start with the definition. Continuous variables, X can take any number. In other words, it can be a decimal between, well, it can be anything. So back to this little example here. If I was to take this spinner and spin it, the point of the arrow could end up anywhere between 0 and 1. So now I don't have discrete because it can be an infinite number. We've talked about this already this year. There's an infinite number of numbers between 0 and 1. And incidentally, a rule we might as well get used to now is that in a continuous distribution, all right, each individual outcome has probability of 0. So if I said, what is the probability that I get exactly 0.3? That probability in a continuous distribution is 0. So what can I do with this? Well, I can say the probability between 0.3 and 0.7 is the area under the curve. Now, in this spinner, all of the outcomes are equally likely. So I have a straight distribution, all right, a straight density curve. In the area between here, this has to be 1 high. So the area of this green rectangle is 1 times 0.4. So 0.4. So the probability that X is between 0.3 and 0.7 is 0.4. And this probability is no different than this probability because the individual probabilities of it being 0.3 and 0.7 are 0. So this one, and if I just had it less than without the equal sign, would be exactly the same. A little bit more in the last podcast.